let's learn about discriminants. A discriminant is an expression related to some function. In this case, we're looking at quadratic functions that can tell you some information about the roots without ever actually calculating the roots. So the discriminant can tell us some information about the roots without ever calculating the roots. So let's do a bit of background work and see where all of this comes from. Right, we have our minus b formula. X is equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. This formula finds us roots of a quadratic function. So let's use this formula right now. In my first example here, my a will be 1, my b is minus 5, and my c is 4. So x must be minus b minus minus 5 plus or minus the square root of b squared, so minus 5 squared minus 4ac all over 2a. So working this out, x is equals to 5 plus or minus the square root of 25 minus 16, so that's 9 all over 2. So you're going to have 5 plus 3, 8 over 2, so that's going to be 4. And x is equals to 5 minus 3, 2 over 2, so x is equal to 1. So using the minus b formula, I found out that the roots of this particular quadratic, x squared minus 5x plus 4 equals 0, is x is equals to 4 and x is equals to 1. So if I was to draw that and put that over here, what would that look like? So quick sketch, we know that it cuts the x-axis where the roots are, so this must be where x is equals to 4, and this must be where x is equals to 1. Okay, let's have a look at another example here to develop this a little bit further. So here I have another quadratic, x squared minus 10x plus 25 equals 0. Same again, I'm going to use the minus b formula. So my a in this case is 1, my b is minus 10, and my c is 25. So x is equals to minus b minus minus 10 plus or minus the square root of b squared minus 10 squared minus 4ac all over 2a. So this gives me x is equals to minus minus 10 is 10 plus or minus the square root of minus 10 squared. So that's going to be 100 minus 4 times 1 times 20 minus another 100 all over 2. All right, so what's happening here? We've got x is equals to 10 plus or minus the square root of 0 all over 2. Okay, so 10 plus 0 is 10 divided by 2 is 5. So the plus option is 5. And also 10 minus 0 will be 10 divided by 2 is 5. So in this particular case, I got the same answer twice. So I got what we call a repeated root. Okay, so what would that look like if I was to try and draw it? Well, let's have a look here. So if you have a repeated root, you get the same root twice. We should know that that means that the function just touches the x-axis at the value where x is equals to 5. So it kind of comes down and up at the value where x is equals to 5. So 5 in this case is a repeated root. All right, one more example. X squared minus 2x plus 5. So once again, a is equals to 1, b is equals to minus 2, and c is equals to 5. So filling into my minus b formula, x is equals to minus b minus minus 2 plus or minus the square root of b squared minus 4ac all over 2a. So that's x is equals to minus minus 2 is 2 plus or minus the square root of 4 minus 20 over 2. So let's look at this a bit closer here. So x is equals to 2 plus or minus the square root of minus 16 over 2. Now what is the square root of minus 16? Well, if we're sticking with real numbers, the square root of minus 16 doesn't exist. So if the square root of minus 16 doesn't exist, that means we cannot complete this calculation. And remember, this calculation was trying to find the roots of this particular quadratic function, x squared minus 2x plus 5. So since the square root of minus 16 doesn't exist and we cannot complete the calculation, that means the roots of this function do not exist. So it has no roots. Okay, so what would that look like then if a quadratic function has no roots? Well, remember, the roots is where it crosses the x-axis. So if a function doesn't have any roots, then it doesn't cross the x-axis. Okay, so we have 3 different examples here. All right, so we have a lot of detail on this page. We have 3 different examples. In my first example, we ended up having 2 different roots. In my second example, I ended up getting what we call a repeated root. We ended up getting the same value twice, the roots repeated on us. And in my third example, because of the square root of the negative, I ended up getting no roots. So we have 3 different scenarios. The first scenario, 2 real roots. Second scenario, equal roots or repeated roots. Third scenario, no real roots. So we can see that quadratic equations can give us 3 different scenarios. We could have 2 real roots, distinct from each other, 2 different real roots. You can have repeated roots or equal roots where you say both roots are the same. Or you can have a situation where you have no real roots, imaginary roots. And we have an example of each situation right here. Now let's examine this a little bit closer. Why did we get 2 roots here? Why did we only get 1 root here? And why did we get no roots here? Well, it's all got to do with what was underneath the square root. Remember, we got no roots in the example on the right because we had the square root of minus 16. And you cannot get a square root of a negative. So in the third example, why did we get no roots? We had no roots because of the square root of a negative here. So let's put that down. We had no roots because we had the square root of a negative. All right, what about the middle one here? Why did we get the same answer twice here? Why did we get repeated roots? Well, the reason for that is because of this 0 underneath the square root. 10 plus 0 and 10 minus 0 is the same thing, hence why we got the same answer twice. So because of the square root of the 0 here, we ended up getting a repeated root situation. So repeated roots happens if you have the square root of 0 in your minus b formula. And then the example here on the left, we got 2 distinct different roots because we had the square root of a positive number, and 5 plus 3 divided by 2 gave me 4, and 5 minus 3 divided by 2 gave me 1. So in the example on the left, you're going to have 2 real roots if you've got the square root of a positive value in your minus b formula. Looking a bit closer, that square root, what's underneath that square root is the letters b squared minus 4ac. So it really is about what do the letters b squared minus 4ac tidy up to? Does it tidy up to a negative value, 0, or a positive value? So in other words, if b squared minus 4ac is positive, if it's greater than 0, then you're going to have 2 real roots. If b squared minus 4ac was equals to 0, then you're going to have repeated roots. And if b squared minus 4ac was negative, in other words, if it was less than 0, then you have your imaginary roots. And as you can see, we had an example of each right here. Now we know where the discriminant comes from. So it's important that we understand anytime you're discussing 2 real roots of a quadratic equation, we know that b squared minus 4ac must be greater than 0. Anytime you're talking about a quadratic equation having repeated roots or equal roots, b squared minus 4ac equals 0. And anytime you're talking about a quadratic equation having imaginary roots, b squared minus 4ac is less than 0. So let's have a look at an example of questions then. So first question, analyze the following equation and state whether each equation has 2 real roots, equal roots, or imaginary roots. So the first equation there, x squared plus 5x plus 4. Now we've already seen these equations, but let's have a look at them just in terms of the discriminant. So x squared plus 5x plus 4 equals 0. Now I'm not asked to find the roots, I'm asked just are there 2 roots? Have we got equal roots? Is there imaginary roots? So to figure out that, we just need the discriminant. We just need to analyze b squared minus 4ac. That's all we need to analyze, b squared minus 4ac. In our example, a is 1, b is 5, and c is 4. So b squared minus 4ac, 5 squared minus 4 times 1 times 4, 25 take 16. That's equals to 9. and we know that 9 is greater than 0. Therefore, this particular equation will have 2 real roots. Do one more example for you. Let's say I take part 6 here. 3x squared plus 2x plus 7 equals 0. So we've got the equation 3x squared plus 2x plus 7 equals 0. So once again, I'm not asked to find the roots. If I was asked to find the roots, you'd have to use the full minus b formula that we have here. If you were asked to find the roots, you have to use the full minus b formula. But I'm only asked, do we have, 2 real roots, equal roots, or imaginary roots? So in that case, I just care about the discriminant, the b squared minus 4ac. So once again, in this example, a is 3, b is 2, and c is 7. So my b squared minus 4ac is going to be 2 squared minus 4 times 3 times 7. So that's going to be 4 minus 4 3s are 12 by 7 is 84. So that equals minus 80. Now minus 80 we know is less than 0. Therefore this particular equation will have no real roots, or sometimes, as you've already seen, we call that imaginary roots. So that's our introduction to discriminant analysis. Your best bet is to practice some of these questions, check your solutions, and for access to questions, solutions, graded quizzes, and more, visit www.limbymaths.com.